morning, everyone. I think we'll go ahead and get started. A few others might join, but I see the initial rush in. So thank you for joining us. I'll be your host, and I want to start by just thanking you all for joining. So today's webinar, we're going to focus on building in Microsoft Azure with HashiCorp automation tools. So Gary Buckmaster and David Wright are going to really be your hosts today and walk you through everything. So we're going to talk through infrastructure as code, what it is, why it's important, and the trend that's driving the way resources are provisioned in the cloud. You'll then have the opportunity to get hands-on with these tools in our own sandpit kind of playground environment and ask questions to better understand what you can achieve using these tools in your own environments. We're going to start this. The total session is 2 hours. So the first hour or so, we're going to walk through more, giving you the background on information, setting everything up, and then we'll have a full hour to really go through the lab exercise. So to start, Gary's going to walk you through an overview of infrastructure as code, as well as best practices using HashiCorp Terraform, creating that environment to deploy resources in Azure. And then after that, David's going to provide a brief overview of Terraform and kind of, the foundational elements of that. And then we'll go into the lab, which, as I mentioned, David and Gary will be leading. Dan, who's on the line, will also be around with some others to help you through the Q&A. So with that, let's go ahead and get started with Gary.
Okay, hi everybody. My name is Gary Buckmaster. I am what's called a technical architect based at the Microsoft Technology Center. So I'm based at the Microsoft Technology Center here in Sydney. Unfortunately, right now with everything that's going on, I don't have a chance to take you all into the MTC, but once we open back up, I'd love to see all of you come by and look at all the toys. In terms of introductions and stuff like that, I think David, probably it makes sense for you to do a quick introduction as well.
Hi everybody, so David Wright. I am responsible for the alliances and partnering and SI partnering across APJ. I've been fortunate enough to be working with Gary over the last 6 months, coming up with cool ideas like this and mechanisms that allow us to talk about how our Terraform and our product can help Azure and Microsoft drive and come up with a common architecture around how we can help.
So now, Dave, was the plan for me to go ahead and start presenting? Because I think right now you're still presenting the deck.
Yeah, let me stop and you can share that deck, and
cool.
You can, it's in for you to share. There you go.
No worries. All right, and so in just a quick second, you guys should all be able to see my version of the slide deck. I hope everybody's able to see that all right.
Yep, we can see Gary, thanks.
Cool, no worries. So for those of you who want to play the home game, there's the link right there, so you can go ahead and grab the slide deck, make it your own, make it extra pretty. And hopefully this is going to let me change. There we go. So this is basically what we're on about today. For those of you who have never touched Terraform in anger, this is going to be your opportunity to have a good play with it, get an understanding of what Terraform is, and also most importantly what it isn't, because there's a lot of sort of misrepresentations about what Terraform is really, really good for. We'll talk about the basics. We'll actually go through an actual hands-on lab where you're going to be able to touch Terraform, deploy some Azure infrastructure, and get a chance to play with some of the toys. By the end of this lab, you will have deployed a working web application. So buckle up, it's going to be quite a lot of fun. Quick little introduction to Terraform and specifically how Terraform is used to control Azure infrastructure. Sorry, David, was there a piece to this that you wanted to talk in on, or are you happy for me to just go straight through?
No, I'm happy for you to go straight through. I think it'd be great to hear, from your perspective around how these fit in and the differences between, native tools and some of the Terraform tools, and where those advantages and particularly from your perspective, how you see that those values kind of coming through and how we can help you drive and make life a lot simpler for consumption.
Yeah, fair enough. Okay, so I just want to make sure that I'm not stealing anybody's thunder here, because I'm obviously coming into this from a very Microsoft point of view, but I am very much an open source advocate and love the open source community. In fact, I've spent most of my my career playing in Linux machines, so I'm obviously very aligned to the Hashi stack and a huge fanboy. When it comes to using Terraform to provision infrastructure, and again, regardless of where you're provisioning it to, one of the neat things about Terraform is that you can provision it into multiple different cloud environments, whether it be a public cloud environment or whether it be something like VMware on premises. The tooling works consistently. So in this particular scenario, we're talking about provisioning infrastructure into Azure. And so basically what you need to do is give it a few basic ingredients that you need. So if you're provisioning just a straight VM, you need to give it a few bits as far as what you want to provision, and then point it at the Azure CLI or the Azure API, and off it'll go provisioning what you need. You can obviously do all of this straight through the portal and get into ClickOps. I think everybody who's on this seminar probably has had some indoctrination into DevOps and understands that DevOps is sort of the opposite of ClickOps, trying to get people away from this idea of going to a portal, clicking your way through stuff, doing everything manually. But you can actually go and do all of this. So, and in fact, there's definitely a subset of people who are doing their infrastructure provisioning using Terraform, and then going into the portal and going and doing some last minute configuration and things like that. There's nothing inherently wrong with that, other than obviously you're going to run up against a couple of DevOps aficionados who are going to say, no, thou shalt perform everything in an automated fashion. Just understand that the goal, the real value for getting into DevOps and being able to perform infrastructure at scale is to be able to automate everything. And that's from provisioning, that's from testing, and certainly from deployment. So if we're going to go and provision this, I'm assuming that everybody here at least has a fundamental understanding of Azure. If you were going to go through the Azure portal, you would go and select a virtual machine that you wanted to go and provision. Alternatively, you can use ARM templates. For those of you who've not used Azure in Anger before, ARM templates are very similar to cloud formations. It's a big, huge JSON file that you can throw to the Azure API, and it will go and provision exactly what you have handed to it. So anything that you go and provision in Azure, you can provision a single virtual machine. You can provision a very large workload with multiple servers, multiple VNets across multiple locations, and all of that condenses down into a big JSON file that describes that infrastructure. You could then take that JSON file, normalize it, hand it back to Azure, and you could stamp out new versions of your Azure environment based on that ARM template. It's a very popular way to do things. Terraform is an alternative workflow for doing exactly that, and there's some advantages to using Terraform, and so we'll talk about that here in just a little bit. So this is what Terraform looks like in its simplest form. So by the way, let me go back a slide really quickly. So this is just a small piece of an ARM template that would be used to provision that virtual machine. There's quite a bit more involved with this, but this is all you need in order to provision a virtual machine inside of Azure. And you'll notice that it's actually quite a bit easier to read. And that's one of the major advantages to using Terraform, is that the DSL that they use for describing infrastructure is very readable. It's very easy to start from scratch to go and provision. So what is Terraform? David, do you want to give the HashiCorp official answer to that question? Because I've got my version of it, but I want to make sure we're answering it the official way.
Sure, and I'd like to hear yours as well, so that would be really good.
Oh, I will.
So from Terraform is an infrastructure as code mechanism, and so as Gary rightly said, this is a mechanism we're looking here to drive and establish, and talking about that process. And so what Terraform has done is take the HashiCorp control language, which is the underlying core code mechanism that is the descriptor as you see it here, and create a very easy to read, human to machine understandable. So obviously being able to drive that API component and being able to actually understand an execution path. So obviously with infrastructure as code, and this is, you know, speaking from my own personal experience is that better? Is that better? Just had the low voice. Yep, there we go. Coming from a cloud background, got myself working with one of the cloud providers. I came in with a very prescriptive idea around how infrastructure as code was written and how it worked. What I found with Terraform is that being able to understand the coding structure and understand how the delivery and formatting and some of the constructs around allowing us to create repeatable patterns meant that as I moved between different clouds and started to work on multi-cloud or hybrid cloud or in those different subsets of even within multi-region, I didn't have to keep understanding or learning what the code needed to do. All I needed to do was understand how the API was driven. So it created that almost simplification in terms of the execution and only having to take the small steps of understanding how to drive APIs and drive the actual outcome. So that's what Terraform is from our perspective. I'd be interested to hear what the Microsoft or your approach from it.
I should probably clarify and say that this is not the Microsoft official answer. So this is going to be my personal perspective based on having played with a couple of different cloud environments, both VMware and other on-premises environments, including, yes, OpenStack, and then obviously having played with the big three and a few of the other cloud providers as well. Each of the cloud providers has some form of code or some form of automation for standing up infrastructure. And each one of those has some advantages and some disadvantages. I'm not really here to throw stones at them, but the challenge is that for many of us, multi-cloud is a reality, or whether you want to call it multi-cloud or poly-cloud, you're going to have infrastructure that sits across multiple different cloud environments. And the problem with that is that in order to then go and start to provision stuff at scale or manage stuff at scale, you need to now sort of stop for a second, switch gears to what's the tooling that I use for that particular cloud provider? How do I do that? Is all that tooling up to date? Is there new stuff that I need to go and make changes to in order to go and modify that infrastructure? And that gets really complex, and there's an opportunity to really put a foot wrong with critical infrastructure and cause outages. So with something like Terraform, which is consistent across multiple different cloud providers, you now have a tool set that's consistent, and you can quickly go and start to do work in whatever environment you happen to have, wherever it happens to sit. Now, I'll talk about this in a minute, but I'm going to just preface this to say, does this mean that the same Terraform template can be used across multiple cloud providers with minimal changes? The answer is no. I'll talk about that a little bit more. But for me right now, the answer to Terraform, or the problem that it solves, is not having to switch gears mentally and within my tools to be able to go in and work on infrastructure and not have to worry about which cloud provider I'm in.
Okay, I think that's a great sum up. Yeah.
Cool. Just wanted to make sure we're all happy with that. I know that's controversial. I'm sure somebody from Microsoft will give me some feedback about that later. So infrastructure as code, I think everybody here probably gets it. I don't necessarily have any problems with this particular definition of it. At the end of the day, the whole point is if I can look at a piece of code or a file that describes my infrastructure, that makes it very easy for not just me, but anybody else who works on that same set of infrastructure to understand what it is. So there's a lot of value in being able to use the same sorts of processes that developers use to manage software and use that to manage things like code and infrastructure configuration. So it lets us work on a codified workflow to create infrastructure, basically the same workflow that developers use. So you check something out from a repository, obviously GitHub, woohoo. but any sort of code repository lets you to version your infrastructure just like you would software. That's a really valuable workflow. Also doing things like testing your infrastructure and using automated unit and integration tests is a really powerful way to test your infrastructure. And then of course, there's lots of automation opportunities there. Changing and updating existing infrastructure is really important. We don't just fire and forget. You know, infrastructure is constantly changing. You're needing to upgrade or make changes to it on a regular basis. And so having code that allows you to do that and track the changes and control those changes is really valuable. Testing is really important. Terraform Plan is obviously a piece of that. There are a really nice set of there's a really nice ecosystem around Terraform now that has nice test harnesses and things like that. So you don't just run a plan. There's potentially ways to do unit tests or fully automated configuration or integration tests for complex environments. And so being able to test that in advance before you actually go and make a change on a live environment is a really powerful capability. And then obviously being able to integrate with your application workflows. Obviously, I'm a huge fan of Azure DevOps, but whatever CI/CD tools you happen to be using, or even if you're just using Git and Git Actions to do your deployment, these are all really powerful capabilities to be able to have one single pane of glass that manages everything from code development all the way to pushing your code into production. And obviously being able to provision infrastructure as code as a piece of that. And this is really powerful too. So I grew up living off of wiki pages that had been either written or semi-maintained by people who had worked for the company years before. And there's lots of little bits of knowledge and nuggets that are in there. And so when I needed to go and stand up a new server, or I needed to go lay hands on somebody's existing server, there was always this tribal knowledge about this is the best way to configure this type of server for this thing. And there were always configurations that were in there that nobody's really understood why we did it, but we just always had done it that way. And every time I changed companies, that tribal knowledge would change. And sometimes I'd run into conflicts with the thing that I had learned previously. So the value to being infrastructure as modules makes it very simple to have repeatable ways to provision something. So if I have a virtual machine, for example, it's let's say it's a CentOS virtual machine, I want to be able to make sure that every time I provision that CentOS virtual machine, it's consistent. It has the same configuration that all the other CentOS virtual machines have. Now, it looks like my camera is frozen for me. Is that frozen for everybody else in a really awkward pose?
Yeah, it looks like you got a sore neck.
Yeah, wonderful. Let me go ahead and stop and restart that one. Not to say that I'm vain, but that was a particularly bad pose. Cool. So going back to my little diatribe here about reusable modules, when I have a module that anybody can go and check out, modify, and share back, it makes it very easy for multiple people to collaborate on the best practice for setting something up. Whether it's just something as simple as a web server or something as complex as a Kubernetes environment, you know, there's a lot of configuration drift that can happen, and being able to have everything in an easy module rather than having to go onto 3 or 4 different Stack Overflow articles and firing incantations at an operating system, hoping that you're doing the right thing. This just gives you a lot more of a consistent way to provision infrastructure, and ultimately is going to save you a lot of drama in the long run. And this is a really important one. I think probably 8 out of 10 customers who come through the Microsoft Technology Center right now and are having some sort of a conversation about cloud adoption, one of the big problems that they're having right now is enforcing security and or governance, and that can refer to a lot of different things, but basically organizational standards around their cloud environments. They want to make sure that they're protecting against cloud sprawl, making sure that people aren't deploying things in insecure fashion, or that they're falling afoul of governance or you know, actual Regulatory concerns. So data residency is a big one, for example. If you have a cloud provider that has, what do we have, 60 announced regions now, with New Zealand being the latest cloud region that we're starting to stand up. If you have the ability to provision infrastructure in 60 different geographies around the world, and you have a tight data residency requirement that says you shall not provision data outside of the borders of Australia, it's very simple for somebody to put a finger wrong and accidentally provision something in the wrong place. So having a very structured way to enforce security and governance across your environment as it's being stood up is a really powerful capability, and using an infrastructure as code tool is a really powerful way to do exactly that.
And just on that point as well, Gary, one of the kind of big differentiators. So a lot of what we're talking about here in Terraform is available in the open source, but there is actually a commercial, an enterprise version of Terraform. And so in that enterprise version, a lot of the tool sets that we see customers asking for around these types of security concern, we have a feature called Sentinel. And so Sentinel is a policy as code element that uses the same language structure to enforce policies around exactly those things that Gary was talking about. And one of the interesting parts is we just recently, in the last two weeks, released a library, so a foundational library that we leverage a lot of the CIS standard policies and best practices to actually introduce those policies as code. So what that would mean is, as part of your Terraform run, you can actually apply using Terraform Enterprise those policy constraints using code. So instead of having to do reactive security around how to then find the holes and patch them, you can do preemptive and stop infrastructure actually being built without the right security elements around it. So it's a really powerful feature around being able to apply those components.
Yeah, and just to echo that, so almost every major cloud provider has some sort of governance capability baked into the fabric. The challenge then goes back to this whole issue of every time I change cloud providers, I have to now make sure that I'm using whatever governance tooling they have and make sure I remember it and have it set up properly. So having one consistent set of tools that works across multiple different cloud providers just enhances that workflow. And if you've not had a chance to play with the Terraform Sentinel tooling, I encourage you to give it a look and have an opinion, because it is a really powerful capability. So last but not least, enable collaboration between teams. This is more important than I would ever have thought, now that I've really had a chance to see how DevOps teams are starting to get folded into big enterprise. So in big enterprise, you're going to have multiple different teams. Some of them are going to be really old school operations teams that, you know, they love servers. They go into their server room and lay hands on their bare metal, and they just love it. And then you're going to have data science teams, for example, who are just wanting to be able to stand up as much infrastructure as possible to be able to run some machine learning experiment or something along those lines. And they really don't care about things like physical servers. When you have a really tight collaboration between a cloud operations team who is providing infrastructure almost as a service to their individual teams and abstracting away what that infrastructure actually looks like, it can be really powerful, but can also sort of abstract away some of the complexity and take away the ability for some of the teams that need to use that infrastructure to use it to its best capability. So when you expose your infrastructure as code as modules that can be checked out by an interested team, they can submit pull requests back to you, for example. That becomes a really powerful collaboration. I keep using that term powerful, but it really is, because when you see it done well, you really see how quickly teams can iterate. A customer of ours that has been really open about their use of Terraform, they do it very well, is AGL Energy. And I really would like to highlight them as a company who does best practices around using Terraform, using Azure, and exposing their modules, their Terraform infrastructure modules, out to their teams to help them to collaborate. So they've been talking about it. There's a lot of meetups and things like that members of AGL have talked about what they've done. And anybody who wants to sort of see some best practices, I would encourage you to take a look at AGL specifically. So other tools that are out there, obviously Terraform is fantastic. My first foray into using infrastructure as code was with Puppet. So at the time when I was looking at it, there were basically two tools that were out there, CF Engine and Puppet. And Puppet seemed like it was a little bit more mature at the time. But you can use a lot of these tools. Ansible is definitely very popular in the marketplace. I would say Ansible today, and David, tell me if you disagree. I look at Ansible, Chef, and Puppet more as configuration management solutions rather than just pure infrastructure as code tools. It's not to say that there's anything wrong with that, but they definitely excel more as configuration management tools rather than just pure infrastructure tools. Is that you agreed with that?
That's very, very much the line that we see as well. And we in a lot of cases with customers, we work collaboratively across that tool set as well. So, Terraform as infrastructure as code is creating your building blocks, is creating those elements that you're going to define. Whereas Puppet and Chef and a lot of these tool sets are actually pushing then, how do I push a standard configuration or SOE to infrastructure that I have? Now, obviously there is overlap between both of those functionalities, and there are mechanisms that you can use within Terraform that can also push config and code elements with remote execs and SSH connections into infrastructure that we've built. But is that necessary? That's at a simple scale. Would that be the way that I would look at trying to prevent configuration drift across my firewall fleet? Maybe not. And so looking at how and what it is that you're trying to achieve is obviously fundamental in picking the right tool. And I've worked in education and large scale infrastructure elements, with over 1 million, 500,000 plus desktops and over 1 million users, where within those environments you know that you need a tool that is reliable, repeatable, and dependable to perform the function that you're trying to achieve with it. And yes, sometimes we do a little bit of pushing the boundaries with the tools that we have, whether that's through cost saving or optimization or familiarity, and to simplify the learning curve. But it is fundamentally, what is the right tool, what are we trying to achieve, and then deliver that outcome. And even that outcome is flexible. So if you build infrastructure and then push SOE to it, that's one way of doing it. If you build or have golden images and standard images that stand up and are built with something like Packer, which is one of our image building tools, that's another way of having a predefined set of outcomes that you have as part of your infrastructure as code philosophy. And I think one of the great advantages of the tooling is there are tools that allow you to build in a philosophy that is best for your business, creates the business outcome as fast as possible, and then allows you to do that repeatably. And I think that's the key thing is how do you get your outcome or how do you get the outcome repeatably and reliably, so that you then move away from handheld infrastructure as code, i.e. I'm manually kicking this off, to some of the things that Gary's talked about, where it's fully automated. You trust your testing tools, you trust the outcome. So literally, a developer or team makes a commit into a repository, that code then automatically kicks off all of the changes necessary without human intervention. And particularly, in the world that we are in at the moment, where speed, agility, and not being able to be present to handhold it is becoming more prevalent. That then also becomes an important factor to think about how you can build those tool sets.
And it's probably worth calling out, and I noticed somebody mentioned it in the chat. So if you look at the tools and the way that they're aligned here, it shows a certain underlying bigotry. And I'm going to hold my hand up and say I'm an operations bigot. I was on that side of things, and so I tend to throw rocks at developers and call them cowboys and things like that. But when you look at the tools that are here, Chef, Puppet, Ansible, those are all tools that are very aligned to the way that operations folks tend to work. There's very clear configuration files. You hand the configuration file off to a tool and it goes off and does a thing. Whereas if you look at tools like PowerShell or just writing complex bash scripts or things like Pulumi, for example,
We lost you, Gary. We lost you.
did you lose me?
Just as you were about to talk about Pulumi. So
Oh, okay. Can you hear me now?
We can, and it's very apt that you got cut off when you're just about to talk about Pulumi.
All I was going to say is, so when you see Pulumi, you see Bash, you see PowerShell, these are tools that are much more comfortable for somebody who has a software development background. The point I would make is, because somebody's going to ask the question, what tool is best? And I'll answer that question for infrastructure as code or configuration management the same way that I would for somebody who comes to me and says, what's the best monitoring tool or the best backup tool? And the answer is by and large the tool that you know really well and it's been solid for you. Everybody has their particular monitoring tool that they love, or don't necessarily love, but they can make it work. Almost nobody loves their monitoring tool. I grew up sort of playing with Zabbix for a long time, and so I know it pretty well, but I can still throw rocks at it. So tools like PowerShell, Bash, Pulumi, those are aligned more for people who are software developers. For me, the problem with those kinds of tooling is that the learning curve tends to be a little bit on the steep side. You have to be able to look at the code, the way that it's written, how it flows. Whereas looking at a straight configuration file, like a Puppet manifest or a Chef or an Ansible configuration file, obviously Terraform is very, very readable. You can look at it very quickly and understand exactly what's going to happen. So that's kind of my viewpoint. Again, I come as an operations bigot. I like to throw rocks at developers. So I think I covered this, but I'm just going to go ahead and cover it again. We didn't do too much to hide who brand A and brand G are. So I think, look, let's talk about the elephant in the room. There's basically a bunch of big cloud providers and then a subset of other cloud providers that sort of sit in niches, and each one of us has our own set of tooling for doing some sort of automation provisioning or automated management of infrastructure. The challenge around all of that is that you now have to know that particular set of tooling. You have to have a pipeline or a workflow that works for that set of tooling, and you have to keep it up to date. And every time you add another cloud to your playbook, now you have to have another environment or another set of tooling that you use to manage that. And it gets complex, it gets difficult, it makes it very difficult to onboard new operations or new developers into that, because now they have to go and learn that set of tooling and workflows. So using a set of tools like Terraform and the other HashiStack tools gives you a consistent way to interact with all of those major cloud providers, a lot of the quote unquote niche players, as well as the infrastructure that you might have on premises, and it gives you a consistent set of tooling and an ability to work across all of those without having to have bunches and lots of different screens that you have to move back and forth between.
Just one point on that, Gary, that I get asked quite a lot, and something that I don't think comes through clear enough here as well is the other advantage of Terraform is you can use this to drive infrastructure on premise. So we have providers that will tier into OpenShift and VMware. We have providers that will drive F5. You can actually drive and set up F5 load balancers and Cisco ACS. So you're now having that infrastructure as code tooling that not only is just cloud specific, but is also around infrastructure specific. It will allow you to deploy whatever it is you do for your infrastructure, and the agility, flexibility, and advantages of running infrastructure and code can be brought into your on-premise component. And the other big question that we usually get with this slide from customers is that they go, well, can you write the same thing at all of those, against all of those clouds? And of course you can't. The API, just the fundamentals. I come from a networking background, and if you just look at how each of the providers have done networking, it's completely different. The fundamentals behind it is different. Yes, you're still using routes, you're still using IP addresses and subnets, but the philosophy and the mechanisms that you need to take are completely different. So writing against that is obviously unique to those elements. But one of the important things that I had as a light bulb moment, and Mitchell, one of our founders, has a really good video on it. I would go and suggest you go and look at it. Is he talks about workflows, and this concept of how a workflow is different from the actual workload. And so when you write code, you're writing it against a workload. You're defining that workload. But what we're really saying is the flexibility around infrastructure is defining how you can do that workflow. And so a workflow could be, I have a network component about in a network deployment mechanism that allows me to deploy in each one of my cloud providers that I'm using. And that then feeds in a data set that allows me to deploy a common K8s architecture. And within that K8s, we deploy a common set of other controls. So now you have repeatable sets of code that drive elements to get that workflow outcome, with only the unique code that you need to repeat against that particular provider. And that repeatability and that modularization again becomes really powerful in terms of being able to reuse that code. So saving you heavy lifting. Back to you, Gary.
No, I was just running that in. I agree with you 100%. The other piece of that no, I think we've pretty well covered all of that. I too quickly wanting to go and start throwing rocks at cloud providers, and that's never a good thing to do. But yeah, it just really helps you to stop from having to switch mental gears too much when you're working across one example. So I'll use VMware as an example. Every single one of us, AWS, Azure, and Google all now have a VMware offering that's stood up in our data centers. And so there's a lot of customers who want to run VMware in a cloud provider and put it adjacent to other cloud workloads. And so being able to use a consistent set of tooling to be able to manage that VMware environment that's sitting in a cloud provider, that VMware environment that's sitting on premises, as well as whatever the cloud infrastructure that they're using, being able to use that all as one single set of tooling without having to work too hard about thinking about, oh, okay, which stack am I working in, becomes really liberating.
Definitely.
Cool. Yeah, cool.
Yeah.
All right. This is your joke, so I'll let you tell it.
Oh, I think I'm just conscious of time, so I think
Yep.
if we flick through into getting into some of the bones of it, we can get through and make sure that people have plenty of time to do the hands-on.
Yeah, that's my preference as well. I think I threw enough rocks at Terraform versus JSON, but I'll just reiterate this real quick. You can see how much more readable the Terraform HCL is versus its equivalent in JSON. Again, this is a snippet of an ARM template. It's not to say that an ARM template is bad. It's just from a readability perspective, Terraform definitely has the advantage. Why Terraform? So this is important to understand, is that the reason why me as a Microsoft employee is sitting up here and doing this conversation is that we inside of Microsoft love Terraform. We work very closely on the provider, making sure that it is as close to what's available in Azure, supporting all of the various services. So we've got folks like Corey Saunders who are talking about it. And for those of you who aren't aware, there's actually an internal team who have built out a very powerful set of capabilities to be able to build what we call a landing zone using Terraform. So this conforms to what we call the Cloud Adoption Framework. And if anybody's interested in that, it is on GitHub. I'll share the link a little bit later. But it's being done by a set of Microsoft employees based on Terraform. So why Terraform on Azure? I guess this is the controversy, right? This is where we cover the controversy.
I don't think it's that controversial, but
No,
yes.
no. Yeah. So I think we've covered it pretty well, but I want to just make sure that we understand it. It does support multi-cloud environments and hybrid infrastructure, and you can obviously use your definition of what a multi-cloud is or what a hybrid infrastructure is. I think everybody's going to find some sort of a Venn diagram that fits across all of those. Allows you to migrate from other cloud providers. Obviously, the goal should be to migrate directly to Azure from all other cloud providers. Clearly, that's what everybody here is doing. But no, it allows you to create equivalent infrastructure in a different cloud provider so that if you're moving workloads between cloud providers, you can ensure a certain level of consistency. Provisioning speed, that's really important. If you were wanting to go and stand up a complex environment, let's say a traditional enterprise 3-tier application with all the bells and whistles, going and using ClickOps to do that is an exercise that can take days depending on how complex it is and how much free time you've got. And obviously going and trying to do that at scale is problematic. So being able to go and fire a set of Terraform templates at Azure and provision things is really a good capability. And definitely I'll put Terraform's provisioning up against me doing ClickOps any day. And with speed obviously comes a certain level of efficiency. Efficiency in terms of provisioning things correctly, reducing the amount of rework that needs to happen, especially if you're going and doing ClickOps. Almost always somebody's going to go and push a hand wrong somewhere. And so being able to work more efficiently and more quickly is important. And reducing risk. This is the most important one. I won't tell this story because we just don't have the time, but I think everybody probably has in their operations team, they have one guy who's sort of responsible for doing all the provisioning, and he knows all the little bells and whistles responsible for provisioning. And so when that person is not available, they're on holiday or they're out sick, all the provisioning stops and somebody else tries to take over, and almost always they do something wrong. So that tends to increase the risk of an outage or having an environment that's not ready for purpose. Being able to programmatically stand up infrastructure reduces that risk. So Dave, I think this is your time for live demo. Is that right?
Yeah, I think what I'm conscious of the time. This is a burn slide for me, so that we can get onto talking about the other components. So what I might do is I will share, and I think getting people onto the hands-on is going to be the best mechanism for that. So
sounds great.
One thing that I will just pivot back on is someone. So Bob mentioned the fact that he saw that it's great the fact that you could destroy your infrastructure and then actually bring it back up when you needed it. Obviously, that mindset around the infrastructure as code also opens up one of the other elements around cost saving, and it's something that we haven't really mentioned, but from a cost saving perspective, it means that you can now really do on demand. You spin it up as you want it. As you don't want it, you destroy it. You save that cost. On Friday, I worked with an organization that would completely spin down all of their dev, test, and non-customer facing production elements on Friday night at 5 o'clock and spin it back up at 6 o'clock on a Monday morning. And so they found that gave them, and it was quite a massive saving. We're talking millions of dollars over that period of time. So this is the other advantage that you're getting by leveraging in that infrastructure as code to be able to create those kind of repeatable patterns that you trust.
Yeah, so I would take the cloud provider answer to that same question, and I'll even shoot holes in it. So if somebody were to come to me and say, hey, I'm trying to save on my costs, I don't want to have my VMs and stuff running all on weekends and things like that, especially my dev test environments. My initial answer is just turn it off. And, there's automation and stuff that you can set up to be able to turn stuff off, and then it'll fire it back up, about an hour before everybody comes in on Monday morning. And it gives you a lot of that cost savings. The value to being able to move to a pure infrastructure as code environment where you're tearing stuff down, shooting it all in the head and then recomposing it from scratch is that in addition to the cost savings, it's also that you now have a way of ensuring that your infrastructure as code is provisioning exactly what you need every single time. So it gives you that comfort level for when you actually need it. that you're provisioning exactly the correct environment and that that's fit for purpose. And so there's a little bit more work up front that's required, and it does sort of require that level of self-discipline, but the value that it pays back in the end is a bit more than just cost savings.
Yeah, well, good point. So we're going to go through the basics of the actual functionality of Terraform for those that aren't familiar with it, and go through some of the core elements. I'm obviously really conscious of time, so this will be very high level, and obviously you have the slides to go back to and look at if you want to. If there are questions, please feel free to use either the Q&A or the chat. They're both being monitored, and we'll kind of fly through this to make sure that people have enough time to experience the hands-on labs at the end to get involved and basically fundamentally get the idea around these concepts. Helps if I click in it. No, there you go. So obviously Terraform open source is easy to provision. There are homebrews, there are binaries, there are Windows components, easy to install, put it into your path, and away you go, and get started writing basically. From a command line perspective, it is a command orientated tool. In terms of deploying your code, you can write it in whatever IDE that you choose, whether that's VS Code or Sublime. I have recently made a switch to using VS Code, which I found.
As you should.
Well, I'm still learning. It's a very powerful tool. I will say that, and I am still at the toddler stages of learning some of the functionality. Put it that way. Because every now and then I go, oh, what have I pressed? And it's all gone away. But from a Terraform perspective, the running and core component of the code is focused around obviously taking that code set that you structured and being able to create that in your declarative model out to the infrastructure. And so we have these common tools, and we'll run through some of these commands. So help is very construct and concise. There are a lot of really clear syntax and error codes within Terraform that allow you that actually tell you what is broken and point to things. Like this line is not doing what it's supposed to, which having come from using other infrastructure as code elements, is very nice to be able to actually go and pinpoint exactly what it is you're supposed to be looking at. So if we just take a look at that code structure, Gary pointed this out and walked through it, but you can see there's a very kind of structured name. So you have a resource. That resource is fundamentally defined with a name. So here we're calling it that virtual network. Defining it what the resource type is. So here it's that virtual network, and then we give it a name. So it's a VNet. And underneath that, you then have these objects. So you have a name, a location, resource, which define individual components that you want that resource to become. And in this case, we're using variables to define what they are. And so we'll talk about that differentiation between those components as well. Obviously, that's kind of just best practice to do some of the commentary and make sure that you actually put in what you're doing. This isn't for you. So just remember, when you're writing Terraform, comments aren't for you. They're for the next person or the person that picks it up after you, or as Gary pointed out, when you get hit by a bus, that then has to come along and actually go, what does this do? What were they thinking? Everything around Terraform runs in a workspace, and this is kind of one of the big differences between enterprise and open source. In the open source world, workspace means one thing, and it's that is the finite entity. In Terraform Enterprise, it allows you to actually share information between workspaces within an organizational component. And so again, to the point that Gary was making about collaboration and some of those, as you scale out around an enterprise, this is that difference between where you get from using workspace as an individual contributor and a practitioner into using it as a mechanism to drive an enterprise. There are some common elements and rules. So we usually expect to see 3 key files. So there's a main.tf, a variable, and an output. So your main.tf is your core code. Your variable is your declaration. These are the individual variables that you want to define. And then your outputs are the mechanism for declaring either information to the viewer, the user, or for actually calling out elements that you want to use in as input for other mains. So you can actually use then reference these as data sources to pull that in, and that becomes really useful for if I write a main.tf that is network focused. How do I get my VPC ID or my security group name or my some of my cluster IDs into then the next piece that's for my application or code set or for my middle tier. So there is a common structure. Within the directory that you're working in, to get Terraform to start, you need to initialize it. And this initialization is where we then see touching on some of the elements around plugins. And this plugin environment is the mechanism that pulls the code core into the Terraform directory to actually allow us to interact with those APIs. And those providers are usually owned by a lot of the cloud providers. So we work and have an engineering team that co-share and co-author with Microsoft around the Azure one. And they work to update, make sure that it has day zero releases and any adds or new services and elements are put into that criteria. You can also pin to a version. So because obviously you've built and spent all this time testing and you've got a particular version of code that you're happy with, it may be that you want to pin it to that version so that the next before the next, or when the next new version and shiny thing comes out, it doesn't go and break any of your changes. So there is a very succinct mechanism to walk through when creating or deploying code. So we go Terraform initialize, which is pulling in all the necessary requirements, and then we have a plan stage. And so plan is a way and a mechanism to understand what are we getting when we do from our declarative code. And so this plans out what you will see. And a lot of the times you'll see this known after apply. Some things we won't know, so we put in this assumption. And so Terraform is really good when Terraform support blueprints. Not off the bat, but we are working, as Gary said, with some of the Microsoft team around creating repeatable modules that would do the same thing. So our modules are those repeatable sets of infrastructure code. So we've been working with them around creating landing zones, for example, as a module. So you have the plan, it now tells you what you're going to get, and this plan also applies, can be reused, so you can actually do this to an output file to actually say that's specifically the plan I want to apply. And so we talked about the variable files. There are a couple of ways that you can define variables. So you can define a variable with interactively. So I want the user to put some form of interactive mechanism in, which is you declare your variable as, in his case, as a prefix, or you can actually define a default. So the variable underneath for a location, we've defined in that this is a default location, and that mechanism is always going to be defined. It will always be central US. What you can also do is, as part of an input, there is a automation process around auto vars TF, which means that once you're writing your code, you define all your variables that you need. You use your variable structure within your main TF to say this location is going to be, you know, region underscore whatever one. And then you can actually use a pipeline or automated component that just creates the variable metric or alphanumeric numbers that you need to feed into this then variable subsequent. So you can really break your code down so you have that separation of this is the code creating a function, these are the variables that I need to define to drive that, and these are the actual input components that I need to feed into those variables. And that allows for that repeatable structure.
And you'll get a chance to play pretty heavily with all of this in the lab. I think there's about 5 different bits where you get to play with variables, define variables, change variable definitions, and then introduce environment variables at load time and things like that. So Edgar, if you still have questions after you go through the lab, give us a shout.
Yeah, and the way that we, just to give people some idea, the way we're going to run the lab is Gary's going to do a kind of an instructor-led walk through with it, and then Dan and myself will be taking on the chat and Q&A to make sure that people have the support that they want as we work through this. So we talked about being able to set some of these components up. Obviously, there is a slight differentiator between and that Terraform.tfvars, which is that mechanism to push configuration elements into the environment, into the variables, and then also being able to set up your environment variables. So one thing that Terraform Enterprise does that really distinguishes between that open source is when you're writing those code sets and putting in environment variables or defining elements, if you write that into your code and then commit that into a public space, you then have a security gap. We've seen customers actually do that. And so what Terraform Enterprise does is actually leverage one of our other products to Vault, that creates a secrets management where you can store those secrets as part of the package. So you can now start to use, principal IDs and sharing those across with people who wouldn't necessarily need to see that privilege, but they can't see it because it's now completely obfuscated and they can't get it back out of the configuration. We'll talk about instruct when we get there a little bit more. So just talking about some of the anatomy, and I know this is going really fast now, but I just want to make sure that we dive through this quickly. You can see that resource, you have the type, you have a common name, and then you have the object. When you refer to and writing out or starting to write out your code, you can see that each resource then has a particular object ID that you can refer to under that. So there are 2 elements. There is a resource and there's a data source, so you can pull that information back. So if you need to say retrieve what the host name is, you can pull that object ID out and start interacting between your 2 pieces of code. I talked about providers and the fact you can pin them. Obviously, this is where some of the power of what, and you'll see it in the lab, is you can see where in this case, if you had in that predefined prefix, Terraform would ask you to input a prefix, and so you would define your name, and that would manually input, and then now the name becomes your an input variable with a unique workshop name. With the location, that location is pulled in automatically, and so now you can see that structure around how code can be written in a way that creates either interactive or preemptive elements, and also uses variables to define your outcomes for your resources, so you're not actually having to physically define these objects. And finally, once you've kind of done all your planning and your code definition, you need to actually define that and push it. So that's where the Terraform apply comes in. And so when a Terraform apply is issued, this will push all of your changes using that code set and actually push that out to the API and drive your infrastructure and make the dependency changes as well. I think one of the things I was most impressed about when using Terraform for the first few times is when you do an apply, it will work out what it needs to do 99% of the time in the right order, and define a lot of those cloud provider dependencies to make sure that the network is there before you try and create a VM, and that the security group is set up before you apply things. So that Terraform provides that in a very powerful component. And with all great things that are built, as Rome and the Colosseum and the Roman Empire, it will eventually be destroyed. Hopefully not quite as spectacularly as they fell from grace. But you can actually now issue a destroy command, and that will then go through and basically clean up. So this is the inverse of that. And both the apply and destroy can also be done around specific objects within your code. So if you wanted to, or had written a complex Terraform main TF that invoked lots of different elements, maybe set up multiple containers or multiple environments, and you just wanted to deploy one part, you could do that. And the same with that destroy, you could just destroy one functional part. So it allows Terraform to actually start taking control of how you drive and create your infrastructure. Some basic components around being able to check formatting and make sure that you have a clean formatting set, but that formatting tool is also ruled into some of the VS Code. So there are formatting and auto-complete within VS Code, hence why I actually moved, because it has a very well-supported developer community that actually write for that, and they provide some really helpful elements when you're writing your or using it to write your Terraform. We talked about dependencies and making sure that you have that dependency mappings. Terraform is very good at being able to work those out. We touched on this as well. Again, I just say that if you are starting to create your files, this isn't a hard and fast rule, but it is best practice. It's what you should be doing. Obviously, sometimes there are elements where you may not need to have any outputs. But usually these are at least the 2 or 3. These are the 3 kind of key files that you should be thinking about when creating. This is just a look at that at a main file and just that simple element. I think we kind of fly through these elements. You can see here with the variable file, you can see that there's different elements and actually defining outcomes. Just conscious of time. And then it outputs. So we haven't touched on this. I will just stop and mention that in the outputs element, obviously this is a way where you can pull information using a variable from the structure within it and actually output what that means. So in this case, we're actually seeing a Vault, setting up of a Vault server, and that's defining a clickable link that you will be able to use to attach to those servers. And so, this also means that you can now pull that value out or you reference that as a data source into another main file if you wanted to actually then cross-populate when using Terraform Enterprise. There is a graphing tool. This can be, I'm kind of personally mixed about this. So it can be a very useful thing, because I know from different people, I am a very visual person. I like to see where's the picture. That's the first thing I will go to in any document is where's the picture, what does the network look like? And I think it comes just from my background of having a network engineer. You look at the plans and the drawings and you go, oh, I understand what that's doing. And then you read what everyone's lied about. The only thing is that I have found is that when this tool outputs, you can land up with a very complex and confusing diagram. So it's a double-edged sword, but it is incorporated and can be a useful tool. There are supporting community tools that you can then feed the output into that actually then pretty it up, create colorization and try and pull some of it apart. I haven't gone through them all, but again, this is one of the beauties of the Terraform community, is that there is a massive ecosystem leveraging all of these elements. I think this is some of the overlap around that, understanding that provision and being able to push a file via a connection into the resource that we've created, and then being able to actually connect to that and actually perform a remote execution. So like I said, this is where that overlap does happen with some of those other tools that we mentioned and spent quite a lot of time talking about. But is it necessarily the right tool to be doing it, and does it solve it for that use case? I.e., if you have built this using a standardized tooling and you have a completely known VM that you are pushing, then maybe all you need to do is kick off that simple element to get it to go. If you have a suite or a fleet of servers that you are managing and there's different drifts and different elements, then obviously maybe one of those other tools is better at doing that, because they have the single master element that sucked up that config, and you're not having to then you know, anything that's dynamic, you're not having to try and feed back into a standardized process. So again, it's where are you at in your automation process? What are you doing, and how, what methodology you've used to approach and attack that. That kind of sums up the same thing. And as Gary said, there's lots of opportunity there. So this is probably one of the big important parts, and I will spend a bit more time on it than I am burn into some of the lab time. But Terraform state. So everything we've talked about at the moment has been very much around the code and declaring it and understanding the actual initialization and deploying of it. What happens afterwards is Terraform creates a state file, and this is that differentiator between some of those cloud native tools and Terraform as well. Is once you've run those cloud native tools, that's it, it's done. And so Terraform actually creates and holds this state file with the version that it is, what version of Terraform it was run against, and a serial number. So if you make adds, moves, and changes, it will track that state. And so you can use that state file to really manage what your infrastructure is at its present stage. Now, obviously, there are going to be components where people add, move, change stuff. So we do have a refresh command that will actually attach the state file. Or you may need to go in and manually add or import an element into it if someone's added it outside of it, or delete it if someone has manually deleted. But you can start to see how now, because you have control and an output around the state file, you can see how Terraform can actually be more than just provision. It can also be around how you manage your overall infrastructure and start to take control of that infrastructure. And so this touches around how you can use the create and destroy, and actually looking at how you can add servers and remove servers if you wanted to change names. There is also some basic functions around the mathematics. So having some of the functionality around like count. So you can set a count number, which means that you can allow for a number of network resources or VPCs or something to be defined. So you could say, I want a count of 2, and then you may want to be able to change that to a count of 3, and it will Terraform will actually then go, oh, I know I've already got 2, I'll update that and just add 1 more. So in that plane, it would say I'm adding 1 more resource. Or if you reduce that number, it would say I'm just removing 1 of those. And so it ties together to be able to really control that state and understand what your infrastructure is doing. And so there are a few different options as well. So we do have Terraform, and that's the open source, is very much the practitioner and that single user. And then to actually kind of start to move away and experiment for larger groups, we actually have Terraform Cloud, which is our managed service, if you like, of Terraform Enterprise. It provides the stepping stone and some of that ability for you to experiment between just as a single practitioner and actually sharing a state between multiples. And this leads into then being able to deploy and what you would do for Terraform Enterprise. But fundamentally, it's around how do we make manage that state? How do we make it so that there isn't state lock? So i.e., as a user, I'm doing this on this state file. I then have a colleague who's working on something else who makes a change, pulls from the repo, makes changes. We're now working on 2 separate two versions of the state file. We make a commitment, and the 2 are obviously out of sync. So managing that state, managing the state files becomes really important as you start to move through that organization and get more and more people collaborating. With Terraform Cloud, obviously, if you want to still keep some local execution, so obviously I want the command line and I'm using it here, but I want the state managed, you can do that using local execution. Or if you want to move it all into the cloud and Terraform Enterprise, you can have remote execution there too. So it takes in and does all the runs then in the cloud or on Terraform Enterprise that you've built. So you're not dependent on just your machine. And that is pretty much all of the elements that I wanted to talk about. So I know it was very fast and dirty, but I wanted to make sure that people have time to get into the labs. What I'll do now is I will send the link around for the labs in the chat, and people should be able to then join. Let me just get this and join the Instruct platform. As I say, Gary will then start to walk through. I don't know if you want to give maybe 5 minutes for people to get kind of set up.
Yeah, let's give people a couple of minutes to get set up, get onto the platform. It does take a minute or two to bootstrap and load, which is fine.
Yeah. So, oops. So I've just sent the link out for everybody in the chat window. There we go. So Dan and myself, I will go on mute. We are monitoring the chat and Zoom and Q&A panels. If you have any questions or issues, let us know. One thing that I will mention is that if you do have problems getting the session to initialize or start, particularly as we have a relatively large group here, it may be just a provisioning element. So what I would suggest is to actually close the session and hi, where is the link? There. I'm not seeing the link to the labs. To all panelists. I've put it.
Gary, hang on. So you're sending it to all panelists and attendees here. Let me.
Hang on. Yeah. That's why.
This is where that Zoom platform is fantastic.
Hey, we promised not to mention the war. Okay, there you go. And it's completely thrown me off my track. What I was talking about. Oh yeah, so Gary will walk through in terms of being able to do a follow the instructor, and Dan and I will monitor these panels. So if you do have problems with it initializing, just dump the session, wait a few minutes, and then just restart from the link. And we have found that helps just purely in I think it's when we have a large group all trying to provision the resources from the platform at the same time. It seems to be something specific for the platform. So I think they just obviously struggle to cope with high spikes. With that, I will stop sharing. I don't know if you are ready to share, Gary.
Yeah, I am.
All right, so I've stopped sharing. You can.
I will share my screen. This one. And I think you guys are all going to see the same thing that I'm seeing right now, which is my environment is provisioning. So my pace for this is going to be pretty slow. I'm not going to go buzzing through it, but you'll notice that the first sort of 5 or 6 objectives you guys should all be able to get through fairly quickly. It's mostly just setting up your environment and getting your hands dirty a little bit. Once we get into there will be a couple where you'll actually have to stop and think for a quick second. So hopefully if anybody has any questions as we go along, ask them in the chat window and we will jump on and try and help you out. I think what's going to happen, David, is I'm going to do this, and since I think everybody else has already jumped on there, I'm going to be the one who doesn't have it provisioned properly, so I'll have to probably do it 2 or 3 times.
Well, at least people will see exactly what we're talking about.
Yeah, no, that's fine. Look, gives us the opportunity to vamp and probably give away more information than we should in the chat. But yeah, by the way, while you guys are waiting, this is your opportunity for general Q&A. If you have any questions, either about Azure, about Terraform, about HashiCorp in general, if you want to ask David about his dog, this is your chance. Okay, so I'm going to wait just a quick second and make sure that most folks have had a chance to get into it before I start off. By the way, when you see this screen, it's not quite ready yet, so
we have one of your very unflattering photo freezes, Gary. Did we lose Gary?
Looks like we've lost him. I'm sure he'll quickly jump on.
Sure,
In the meantime, Dave, you've got a question popped up from Rahul.
Yeah, I'm just answering it actually, so I'm on it already. Yeah, so I might as well verbalize it. So one of the other questions was, can you provision resources in multiple cloud environments within the same module? So main.tf. You can, and that live demo that I skipped over for time does exactly that. Let's see if I can find Gary. Did he come back? What it will mean is that you can just write your code specifically for that function to be able to pull out that element that you want to achieve. So you can quite easily write the code to do whatever it is that you want to. However, that can lead, depending on what the outcome is. So if we talk scenarios, it's probably the easiest way. So the scenario that I have is that I had 3 managed clusters across each of the cloud providers. So AKS, GKE, and AKS, GKE, and was it not EKS? What is it? Anyway, the other one. What I found is that that deployed the common structure across each of those 3 cloud providers, and depending on how you wanted to do it and the interdependencies, that obviously would achieve that outcome. What you may find is though then you may want to actually break that out and manage them separately as different workflows. So because I had written that code set for a demo environment where I stood up all 3 and used all 3 mechanisms really quickly, then that actually suited. However, from a practical perspective and operational perspective, you may not want to be touching that one file that touches all 3 of your infrastructure sets at the same time. I haven't heard from Gary, so I'm not sure where Gary has got to. Dan, do you just want to take over if you've got the lab up? I know you already had it started.
I do. I'm kind of at the end, but let me see if I can rewind.
And I will.
Okay, I'm starting up a new one. I'll have to wait the 2 minutes, but yeah, happy to kick it off if you'd like.
I can see you chatting, but can't hear anything come through, Dave.
Sorry. I said I say, yeah, if you want to just pick that up, and then I'll see if I can recover where Gary is. He seems to have lost everything.
Yeah, he's restarting.
Okay. All right.
There is a massive joke I could make there, and I'm just not going to. I'm just going to rise above the occasion, which is incredibly difficult for me.
Okay, I'll just let my environment come up and then I'll start sharing. I would say anyone that's got the environment up already, those first few challenges are pretty basic, so feel free to step through. We will fly through those first ones. There is a check button on each of the challenges. Sometimes it does, I would call it a real check, and sometimes it doesn't. If you do get a failure in one of the checks, just let us know. Okay, cool, mine started up. I will share. Okay, is everyone seeing that screen?
Yep. You're live.
Okay, cool. Actually, the scaling is probably bad, so let me fix that.
Yeah, so Gary's actually having provider issues. So if you carry on owning it, and then we'll.
Okay, so the first step is really just about the Instruct platform itself. So hopefully you're seeing the same thing that I'm seeing on the screen here. I hope this is big enough as well. I'm sure everyone's got it in front of them. So we'll just push on.
Yeah, it's good then.
Yeah, okay, sweet. Sometimes I do see people with this very first step that the actual code editor, the IDE, so this is VS Code running remotely. Sometimes this won't load. If you don't see this IDE screen, I'd recommend that you go back to the main page. So click the back button down here, click stop on the track, and then click start again, and it will spin you up a new environment. As Dave mentioned, sometimes these environments just get stuck, especially when we're spinning up a lot at once. There's a little tab system up here, so you can switch from the IDE into an editor, and you do have a shell. We're going to be usually sticking in this tab, especially for the first half, and we can even use the terminal in here as well. So not too much to do here. Oh yes, we do want to install the Terraform extension. And that first step is as easy as that. So I will click on in the interest of time. Pro tip, you can click this little green button to go even faster. Once you finish the first challenge, so you shouldn't have to wait too long for it to set up the next challenge. You don't have that kind of two minutes that we had at the very start. So that should be instant. Again, if you're seeing delays in that, just reload and you should get the platform back. So as I mentioned, we can use the terminal within VS Code. Cool, so you should see a usable terminal there. I'm assuming everyone here has a bit of familiarity with VS Code, so I'm not going to jump into, what's good, what's different, what's kind of cool about it. We'll hopefully get to some more Terraform stuff. Okay, great. So here we are looking at the actual Terraform binary itself. Now we are talking about, I think David went through open source Terraform, very suitable for a developer or a single practitioner. This is literally Terraform running locally on your machine. Very, very valid way to work. But obviously, as you scale into a large team, you run into, problems that can come from that. We're going to focus for the moment on running Terraform locally, and this is how we'll interact with it via the CLI. Like with a lot of these tools, you can find out what the available commands are just by typing in Terraform itself or looking into Terraform help. The nice thing about this binary is you can really run it anywhere and your experience is going to be exactly the same. So we check through that.
He's back by popular demand.
Was it that popular?
Gary. What happened, mate? Do you want to give us a technical rundown?
So the only thing I can tell you is that it looks like, so my provider is TPG, and it looks like they must have done something because a whole bunch of my international routes all dropped all at once.
Oh, wow.
So.
Okay.
Yeah,
Okay.
I don't know if it could be a local thing. I'm happy to throw rocks at my setup, which is quite elaborate, but I think just based on what I'm seeing, I think TPG just had a little minor blip of routing.
Okay, no worries. I've just flown through the first 3 or so steps. Happy to throw back to you or whatever you'd like to do to keep going.
Yeah, keep going for a quick second. It's going to take me a minute to get my environment back up. So.
No worries. Okay, I'll keep stepping through. So what you'll see here, we're just looking at the environment variables that are available for Terraform. Terraform is a tool that interacts with APIs of whatever provider you are interacting with. So whenever you think, okay, I want to provision infrastructure on X, whether it's Azure, the other cloud providers, it could be VMware if you're running something on-prem, you need to think about, okay, what are the credentials that Terraform would need to be able to interact with the API of that provider. So you can see a few of them here. You should see a few things around ARM. Another gotcha that I have seen here is sometimes one of these environment variables won't populate, and you'll see that cause some errors later on when you try to ask Terraform to interact with Azure. I'm sounding like a broken record, but if you do see that, just go back and start it again and you will pick up those environment variables. So that all looks good. So we'll go forward. I don't know why mine is popping back there. Okay, so a little bit on the structure here for your Terraform code. I'm not going to labor this, and as you look into more advanced Terraform use cases, you will see this kind of structure. Some people will stick to it, but most often you'll see this explode out into a real variety of Terraform files. The nice thing about how this works is you can really choose how you want to break up your Terraform code, right? Do I define variables locally? Do I define them in their own file? Do I break out my actual provisioning code by, compute resource and network resource and let's say Kubernetes resources? Do I break it out by cloud? Do I break it out by prod versus dev versus test? You'll see a lot of different patterns around using this. There is some best practice out there, and our website has some best practice, definitely for a simple environment, what you see here. So main TF, which has my actual provisioning code, outputs, which defines, okay, once I run a Terraform apply, what do I want to feed back to the operator? Usually this is going to be a DNS address or an IP address for them to connect to whatever has been provisioned, and variables. So there was the question earlier about variables TF versus a .tf vars file, which I answered in the chat. But you'll see, how we populate these kind of files as we step through. Okay, so the first interaction we have with the Terraform binary itself is this Terraform init. This is kind of telling Terraform, okay, I've got some code. Terraform has a huge amount of plugins, let's call them, you know, that you could be using per provider. So if we're defining, you should see here that I want to use the Azure provider. Once we run the init command, we're telling Terraform, look in my code, look at the providers that I want to use, and make sure you grab everything that we need to be able to work with that provider. The other thing that Terraform will do, if you've defined modules, so you can say, you know, I want to use some Terraform code that has been pre-written either by, you know, the folks at Microsoft themselves or by someone within your organization. If you define those modules, you can pull that code from a remote location into your local directory to start using as well. So that's everything that Terraform init does, and you can see the kind of files that get pulled in if you run that list command there.
Hey, Dan, I can jump over if you'd like now. I've got
Awesome. Everything
back up and working.
All right, I will stop sharing. Thanks very much, Gary.
No, that's fine. I'm sure they probably prefer your accent to mine, but.
I don't know about that, mate. I've got one of those nasal voices. I think you'll do fine.
Well, I appreciate the trust. We'll see if my internet connection stays nice and stable now. So you guys should all see that we're now to the point where it's the opportunity for your first quiz question. So I'm going to just leave it there for a quick second before I answer it. I think you guys are probably already to this point. All right, so this is where we start to get into the inbuilt ability to test and validate your Terraform code. And there's a lot of different tooling that exists. Again, we talk about the fact that there's a really nice ecosystem of tooling that's there. The validate function is there to make sure that from a Terraform perspective, everything is happy and copacetic. If I go ahead and open up my terminal really quickly, I can do a quick Terraform validate, and it's going to tell me that everything is wonderful. But let me just go ahead and break it really quickly. Do what one of my developers likes to do. Let me just go ahead and add a random semicolon in there. And what I really like about it is it gives you very helpful advice as to what's gone wrong. So, you know, this is a fairly trivial one, but when you get into some fairly complex blocks and stuff like that, you get some really helpful feedback from the validate function to tell you what's gone wrong, what line it's on, so that you can go and quickly start to figure out what you need to do to fix it up. Okay, so everything is happy and wonderful again, so we'd now be in a position where we could run a Terraform plan and then apply. And obviously, you see this in the note, it's really good to use validate as part of your CI/CD pipeline. Just make sure that everything is happy and copacetic before you hand it off to a provisioner. So once you're happy that your Terraform code, at least from a structural standpoint, is written properly, maybe you want to do some linting and stuff like that, then you can go ahead and run Terraform plan. And what you're going to get from Terraform plan is an output about what Terraform is intending to actually go and provision. So this is your last chance, really, before things start to go fire off. This is your chance to make sure that what's about to happen in your cloud environment is what you intend for it to happen. And this is also where, if you are writing Terraform code, you can go ahead and prompt the user for some values that you need. So for example, we're going to do some prefixing in front of our infrastructure to make sure that we're not hitting against anything that's already been named that particular thing. So I'm going to choose MTC Gary, which is fine. But this is also where you can do things like prompt for a location where you want to provision your infrastructure and bits like that. And then if I expand my screen here just a tiny bit, you can see this is what's actually going to get created. So in Central US region, something called MTC Gary Workshop. This is a resource group that's being created. ID is going to only be known after it gets applied, and any resource tags that have been applied are going to have to happen after. So programmatically, it's possible to do things like have resource tags and things like that be applied to any infrastructure that gets provisioned. So Terraform isn't going to know about that up front, so it's going to make sure that it goes and checks tags after things have been provisioned. So this is where we start to get into talking about the use of variables, which is really powerful capability. Yeah, so Andre, you asked the question, can we apply tags in Terraform here? Yes, it is possible to do that. And in fact, in the lab here in a quick second, we're actually gonna write a variable for applying tags and stuff like that. So you'll see that very shortly. But yes, it is possible to apply tags on the fly. And yes, so Andre points out that he's got policies that block new resource groups that don't have tagging. That's a really good practice. And again, this is my personal opinion, but it is held up by most of the major cloud providers have some sort of way to assign metadata to their resources to give you some information, like for instance, who's responsible for the infrastructure, what location is it in, how critical is it a development environment, is it a production environment? And if you don't have tags associated with your infrastructure, it's the equivalent of going into a data center and not having servers that are labeled, not having cables that have been traced and tagged. It's done. It's not good practice. It becomes really problematic when you're trying to troubleshoot. And so the use of metadata like tagging, we call them resource tags in Azure, is good practice. And you can do things like enforce the use of tagging and have the Azure CLI just kick it out and say, no, you're not gonna provision this until you apply some tags. And also, David, correct me if I'm wrong, you can have that same workflow happen in Sentinel.
That's right. I was literally just going to say the same thing. We can do it with Sentinel, and also from a variables type, you can actually do lists, and you can filter as well within the main within a main body. So having those tags to be able to say, I'm looking for this resource with this name, or this, you can then filter down based off that tag ID. So yeah, best practice is always to tag elements just from cost optimization and all sorts of elements and business alignment, but also cool. From being able to simplify your code.
Yeah, and if you go and you read the Azure Cloud Adoption Framework, there's a whole opinionated section about what tags you should use, what tags you should require, all of that stuff. So here we've got a variables TF. These are the actual variables that have been defined. And always good practice to have descriptions in there and set defaults. But then this is the actual variable that you can go and set as if you want to override that. So we can set that prefix. And in a second, we're going to go ahead and actually go and change that. Oh, actually, I think I'm meant to do that here, aren't I? So go and change that in. Hit save. And now if I hit Terraform plan, you notice it's not going to prompt me for the prefix. Now it's just going to go ahead and take what's in my TF-vars file. And you'll notice that if it was going to go and provision, it would provision MTC Gary B instead of MTC Gary. So with this, you can have, you'll notice that we have default values that are set. So for example, up here in location, my default location is Central US, but I'm actually going to go ahead and override that. I want everything to be provisioned in Australia. And so while my main Terraform module is still going to have this default preference to the provision in Central US, for me, I'm going to actually provision in Central, or in Australia East rather. So now that I've set that, if I went and run a Terraform plan again, you'll notice that it's now going to change the provisioning target to Australia East. There we go. Quiz time. So where are Terraform variables declared? So this is a tricky one. Just make sure that you remember where it's declared, not where you actually go and do your overrides. This is going to use the graphing capability. David showed that very briefly, but this is going to be your chance to actually go and have a play with it. I've actually had a chance to play with a few of the third-party tools that do visualizations across cloud environments. And David, I agree with you 100%. They're all really pretty, and some of them can be quite useful. But with complex environments, you just get this big, massive burst of information, and trying to wade through all of it gets very complex very quickly. But it is nice to have a quick graphical representation of what the reality of your environment is versus what's been documented or what's been written on a project plan, or even what the code says is supposed to be there. Actually having a third-party tool that takes a look and says, this is what the reality is, really, really helpful. So I'm going to run Terraform Graph, which is going to go and fire off and create something that Blast Radius is going to use to serve. If you've never played with Blast Radius before, it's a cute little Python tool that sets up a little server that is going to allow you to go and visualize. Oh, did I type that wrong? Oh, yeah, serve, not server. So definitely don't do this in production. Like, don't run Blast Radius from the command line, certainly not as a root user. Expose it to the internet, always bad practice, but for our purposes here, it's great. And then I'll just zoom in really quickly so you can see. And again, keep in mind, this is just a resource group. So this is a bucket that a bunch of resources are going to get provisioned into. And this is all the metadata that surrounds that, just that resource group. So this isn't a virtual machine. This isn't a public IP address. This isn't a database. This is certainly not a Kubernetes cluster or anything like that. So you could see quite quickly that for even a fairly trivial workload, you could get a fairly complex graph really quickly. But at least from this perspective, you can take a look and validate that everything is the way that you expect it to. You can mouse over it and it gives you the actual information about what the location is, what the default is, all of the stuff that's in the code. So now it's going to be a race to the finish line to see if I can get this done in 15 minutes. So we'll see how we go.
We have a bit of breathing space if we need to. So
cool.
If we can aim for, yeah, we have a little bit of breathing space. So if we can aim for it, we'll see how far we can get, and we'll reevaluate as on time. So
I'd be curious to know how far people are who are trying to follow along. How many people have blown way past me and are all the way on the ends, or how many of them are actually following along. So those of you who are in the chat screen, it'd be great to know how you're doing here.
Yeah, if you want to just raise your hands or on the and have a look, see how many people are.
Cool. So what I've done is I've run my Terraform plan. I'm happy with the output. It's going to go into Australia East. It's got a resource group that's going to be called MTC Gary B. So this is where now I go ahead and hit a Terraform apply, and it's going to go out and reach out to Azure, and it's going to go and provision a resource group in Azure called MTC Gary B. And it's going to ask me, it's going to say, this is what I'm going to do. Are you 100% sure that you're happy to do this? And I'm going to say yes.
There is actually in Terraform a way to auto approve if obviously you were running this into pipeline and components where you didn't want a manual intervention. But for this purposes, obviously it makes it foolproof. I think it's probably a nice way to put it.
Yeah, and I think that auto approve is actually one of the challenge items here in just a minute, and it calls out the fact that you need to be really careful about running auto approve. For automation and pipelines and stuff like that, it's obviously really important, but just hitting auto approve for everything can have unintended consequences sometimes. So this is talking about idempotency. So we're talking about the fact that Every time I run Terraform plan, it's going to plan what it's going to do. And when I run apply, it's going to reach out to resource and check and see what the state is. And if the state is changed, it's going to be aware of that, and it's going to tell me what's going on. So for example, right now I've got my resource group is called MTC Gary B -workshop in Australia East. If I were to go and change that to Southeast, for example, yeah. Save that there. So now if I want to run my Terraform plan again, it's going to go and realize that a change has been made. And as a result, it's going to tear down the resource group in Australia East that it's created, and it's going to stand up a new resource group in Australia Southeast. And you'll notice that it puts in highlights in red. This is going to do bad things. This could cause outages if you're not paying attention to what you're doing. So be absolutely sure before you run Terraform apply. But I'm a cowboy. I know what's going to happen. I'm happy to go ahead and move things around. By the way, once you get comfortable with this and you start moving whole complex workloads around between regions and stuff like that, just having done things the old way, being able to go and do this gives you this feeling of power that it is a little bit difficult to look past from time to time. When you go and take an entire 3-tier web application and destroy it and then stand it up in a different region, and you just watch it all happen as if by magic, it gets a little bit too comfortable for me.
And the birds I'll go.
Yeah, that's it. Fortunately, I've had enough times where I've had, you know, something that I thought was going to work really, really well and have it go badly wrong. So there's always that quiet nagging doubt that says, is this actually going to happen the way that you want it to? Are you prepared? Kind of like when you're doing a live demo and all of a sudden your internet connection drops.
We all have to make our sacrifices to the demo gods.
That's it. That's it. So this is going to take a few seconds just because it's now tearing things down. Oh. Invalid resource group location, Australia Southeast. Oh. So it looks like it didn't. Oh, okay. So what we've run into here is a race condition. So the resource group still existed in Australia East before the provisioner tried to fire it on Australia Southeast. So all it's saying is that there's you have a resource group in your subscription that has exactly the same name in a different region. So if I hit Terraform apply again, this should sort it all out. Yes, things like this do happen from time to time. No, it's still there. That's all right. I'm going to let this continue to move on just because. Yeah, things like this happen. By the way, every cloud provider has this where you'll have a provisioner or a deprovisioner or something that takes a little extra time or it gets hung and you have to go and kick something before your automation works again.
Yeah, go done, completed.
Yep. That's why don't get cocky. Don't imagine that everything is going to work flawlessly, because invariably the demo gods or the operations gods are going to go find a way to make you look silly. So here's that use of the auto approve flag. Great for the use of automation. So in this particular case, let's see. Why don't I put maybe Australia Central, for example. Let's go ahead and give Canberra some love.
I'm pass.
Damn. Shots fired. I will say, so any of you who've never seen a hyperscale data center or have never seen one of the Azure data center talks, our partner in Canberra Data Centers, who have built the data centers that our regions in Canberra are built into, they've done a beautiful job in building those data centers. And so if you're one of those data center nerds like myself, If you ever get a chance to go and tour any of the Canberra data center facilities, they're fantastic. Similarly, Azure, we do take a select set of customers for tours through Azure data centers. We have a virtual version of that I run out of the MTC. So if you ever want to see what it looks like inside of a hyperscale data center, I definitely encourage you to come and check it out, because it's more than just blinky lights. There's a fundamental reason why hyperscale facilities are built the way that they are, and having an informed opinion about why a hyperscale facility versus an enterprise facility. It's not to say that one is better than the other. It's so that you have an informed opinion about where to deploy a workload for maximum benefit. And then there's other neat things that are in there, like why did we build a data center that we went and dropped into the ocean, and what are our plans around that kind of stuff. So here we go. Just with one line, I've now deprovisioned the environment. I've stood it up in Australia Central instead. I think I see that there might be a question here.
I got it, Gary. I got it,
Cool.
Gary.
I'll let you handle it, Rahul. Yeah, cool. No worries. Okay, so this is the first opportunity you guys are going to have to see me look a little bit foolish if I do this wrong. So this is your chance. So if I want to add a resource tag to the resource group, so this is going back to that metadata, I could certainly just go in here. This is my resource group, and I could go in and say tags equals environment. So I could definitely go and do that. I could hard code a metadata tag that says I have a tag called environment, and then I want to call it production. That's fine, but it's not really good practice to do this. It goes back to hard coding. So what I'm going to do instead is I'm going to go ahead and create a variable. I'm going to call it env tag. Resource tag to describe criticality of environment defaults to development. And now this is where variable types are important. So this is going to be type map. I said defaults to development. Okay, so I'm going to save that. Then I'm going to go over here and say env tags. I did call it env tag, not env tags, right? Yep, cool. So then what I'm going to do up here is I'm going to work off of the variable rather than okay. Let's see if I did it right. So does everybody sort of see what I'm trying to get to here? Is rather than hard coding an environment tag, I've created a variable that defaults to setting it as dev, and then I've overwritten that and declared it as production. Given value is not a so I told you this is going to be your chance to see me look foolish.
Actually, someone's. It's you have to brace it. So the
right, of course. Yep. Good call. Let's see if I've done that correctly now. And by the way, so this is where, you know, Terraform Validate told me that I had completely valid code. And so again, just trusting that from a syntax perspective, everything is correct. That's right. But once you actually start to hand it off to the provisioner, this is where things start to run badly wrong. So definitely don't just trust that your code being valid means that you're going to get the environment that you want. This is where using additional testing tools that are out there, and there's again a really nice ecosystem for testing. So you could be using something from RSpec, or you could be using TerraTest, or whatever test framework you happen to like, so that once you actually have something provisioned or you're about to turn something on, you know that what's actually been provisioned is what you want. And now I'm definitely behind the 8 ball, so I'm gonna have to move it along. Thank you for whoever popped that into the chat. I didn't have a chance to see what it was, but I appreciate you calling me out on that. I know that that's going to apply properly, so I'm just going to buzz straight through, if you don't mind. Yeah, cool, it got there. Now, for those of you who are just starting out, the great thing about this is it can be built incrementally. So you can start with a resource group and then add network, then add infrastructure, and it'll just keep building. So we're going to do exactly that here. Initially, all I've got defined is my resource group, but now inside my resource group, I'm going to define a virtual network, and I'm going to go ahead and define some security groups and things like that as well. I'm just going to define the virtual network and give it a subnet for right now, but we'll add to that in a minute.
So obviously for our attendees, we've still got 27 people. I'm happy to continue going on if you are, Gary, and just keep this going for a little bit.
Yeah.
So if those 27 want to stay with us while we just run through to the end, then please feel free. If you need to leave, obviously we understand given the overrun. So we'll just carry on for till we get through to the end of this, and hopefully people can stay with us.
And this lab is going to be around for the next day or two as well. So if those of you who haven't had a chance to get all the way through it, or if you want to go and revisit it again, it'll be there for you to go and have a run through. I really appreciate, by the way, those of you who are sticking around. I hope that you guys are getting a lot of value out of it. Definitely would like to hear back from you. Kick us on LinkedIn or whatever your social media venue of choice is, and let us know how you like the workshop. David, correct me if I'm wrong, they're also going to get like a little feedback link. Is that right?
I'm not sure what's happening in terms of follow-up. So Pete, who I normally runs all of those things, is out today. So yeah, but there will be a follow-up. We will put some sort of survey and feedback mechanism into there, and there has been a couple of people asked for recording. So we may well include a link to a recording as well, depending on what we see. So yes, some definite follow-up mechanisms for people to put their worth. The other thing with this as well is if you think that this is worthwhile and that either friends or colleagues would gain from running through this session, you know, we also would like to hear that feedback to whether we should run this environment and these academy sessions again.
Yeah, guys, if you're trying to get Terraform into your environment, you're trying to get your bosses across what Terraform can do for them. this would be definitely one of those kinds of environments where we'd like to help educate the masses and get people across it. So yeah, anything we can do to help you, happy to do it. Okay, so just going back to anybody who's still following along in the lab, what's happened now is everything, this entire web application is about to go and get provisioned. So again, the implications of going and doing things like running Terraform, apply, auto approve without understanding exactly what's about to happen, a whole bunch of stuff is about to get provisioned. So just be aware of that in advance before you go ahead and hit apply. So I'm going to answer this live because this is an important question. So the question was, can we bring resources live to a state file? So for example, if you already have something that you've provisioned in Azure and you provisioned it manually, and there's no shame in that. There's lots of people who've been using Azure for a long time and they're just now coming into Terraform, but they want to start managing their infrastructure using Terraform going forward. Yes, it is possible to create a Terraform template that matches your environment and then import the state. It's not in this lab. It's a little bit complex to do, but it's definitely something that can be done. I've got customers who've done exactly that, and they're very happy with it because now they're able to keep all of their infrastructure managed by Terraform, even stuff that was pre-existing their adoption of Terraform. So you definitely can do that. And thank you very much for the question.
And I put a link in the answer to everybody. So there's the import link is now up there too.
Yeah. And by the way, when you're doing that, it's a great time for you to go and fix up the fact that when they provisioned it, I guarantee you they didn't use things like resource tags and stuff like that. So this is your chance to go and add those things. So this is going to continue to fire along. This takes, from memory, it takes about 4 minutes to go and provision, but at the end of it, you get a nice little application that you can go and pop into a web browser and you get to see a cat. So that's important for everybody to do.
Depends whether you're a cat or a dog man, though.
Well, I noticed that the author of this lab environment is very inclusive for anybody who is a cat fan, a dog fan, or a bear fan. So it's really very inclusive lab. I really appreciate that. I actually didn't realize that place bear was a thing. I knew about place cat and place dog, but place bear was new for me.
Yeah, there's lots of interesting things you learn on the journey.
I just love the mindset that looks at something like place cat or place dog and says, you know what the internet really needs? Bears.
Yeah, more memes. That's what we need. More memes.
Oh, that's what keeps the internet going.
Yes. Well, particularly in the current environment with everyone locked away.
Yeah, that's it. While we're waiting for this to go on, is anybody super excited about the coming of xCloud and the ability to play Xbox games on your mobile phone? I personally don't know why I would want to play something like Skyrim on a screen this small, but the fact that I can do it, I'm definitely excited to try.
I think it's also interesting just to look at the fact that this is running through a remote execution. So even though this is creating an execution job on the remote state or the VM that you've standing up, it's actually giving you, cohesive feedback and information around what is happening in terms of that execution. So, again, is this necessarily or the only tool you would need? Not necessarily, but does it do a good job around being able to get you to that point, particularly if you've taken to installing a standard image? Then yes, you can stand up repeatable infrastructure, and this is kind of speaks to that that mechanism around figuring out which is the best for you to actually use and why.
Yeah, it's great as especially as a starting point to give you a whole lot of insight into exactly what's happening with the provision. And also if things blow up, it gives you a really good understanding of where things blew up so that you can go and figure it out really quickly. So I think from memory, this was where, I think there's an interesting little mechanism in the lab that doesn't let me copy and paste. Yeah, disabled by this document by a feature policy. So those of you who actually want to go and see your CAT app live, you'll have to manually type it into a browser. I won't do that here just for time, but I definitely encourage you to do it. It's worth doing. You don't have to be a cat fan to appreciate the HashiCat app. Okay, so going back to now, I'm going to go ahead and run that blast radius against my new environment. You'll see how quickly, again, this is not a complex application. This is a virtual machine with a public IP address and a storage account associated with it. And I'm trying to talk and type, and I'm doing a terrible job of both.
I can't even do both, so you're doing better than I am.
Well, I'm not doing well because I took radium and mistyped serve. Here we go. So when you're trying to describe really complex applications and you're trying to look at it, and you can see really quickly that there's a lot of there. And I think that there's actually, at least the way that blast radius works inside the Instruct platform, there's a display bug or something like that. I can't zoom in and out.
Yeah, there's a bug. So
yeah, no, so those of you who run into this, just realize it works fine if you're running this on your local machine. You can zoom in and out. But again, you remember what was there for a resource group, and now you've got all these other bits that are in here. And again, we're still just talking about the only addition is a storage account, a virtual machine, and a public IP address. But all of a sudden, this whole graph gets more complex. So imagine what that would look like with a 4-node Kubernetes cluster. Okay, quiz time. Yet another opportunity for Gary to look silly if he doesn't know the answer. What happens when you run Terraform apply without specifying a plan file? I love this answer. Terraform runs without any plan. It just runs amok, flipping tables, causing problems.
Yeah, we run into havoc.
Terraform reads the previous plan and then applies it. Terraform runs a new plan right before the apply. None of the above.
And just with some of there is a Terraform associate exam that we've now released. So we're building out the certificate path. So for those that are interested in learning more, there is our learning platform, so learn.terraform.io, which actually, sorry, learn.hashicorp.com, that actually has a learning guide that will work you through the learning path with the exam criteria and setting up all of those things. So if you want to actually take this and get an accredited certificate that you can start to actually, build your own reputation within LinkedIn and promote and get a deeper understanding of the HashiCorp and Terraform language, there is now a cert pass for this too. There will be a pro exam coming out probably this year too.
And correct me if I'm wrong, the pro exam is going to be pretty involved. It's not just going to be, there's not multiple guests and stuff like that. You actually really have to know what you're talking about in order to pass that cert. Yeah,
so the way that it's been built and envisioned is that the associate is a true kind of multiple choice exam type. So do I know the basics, and do I understand how those workflows go? And then the pro will actually be
interactive in that you have to input elements and actually write information into it so that you actually have and can articulate your understanding and demonstrate that you have that level of understanding to get through. The same as a lot of the modern infrastructure exams from different vendors have that kind of stepping through into, you know, do I know the product and do I kind of transition that into actually applying the knowledge? So
yeah, no, it's good to see. So for those of you who are following along, I just started using the remote exec to install the Cause application, yet another really valuable piece of software that should be in everyone's remote exec pipeline. But simply put, the remote exec allows you to run some commands on the virtual machine that you're provisioning. And so while it's not necessarily best practice to go and do every little bit of work in remote exec, it's fantastic for bootstrapping an environment and getting it ready to be handed off to, let's say, a configuration management tool like a Chef or an Ansible or a Puppet. But in this case, all I'm doing is installing a simple application and then running it on the command line. And you can see that I've got my little output here, Cause. Woohoo! I think as a general rule, if your remote exec block is bigger than your main TF block, then you're doing remote exec wrong.
yeah, and again, it goes to that right tool for the right purpose, right?
Yeah, that's it. So here comes your other opportunity to see Gary look foolish today, and which is going to be using the output. So getting some output from Terraform. So if you have the opportunity to get some outputs from Terraform. And I think there's one output right now that just spits out the URL for the HashiCorp app. But what it's doing is it's reaching out to the state file, it's refreshing itself. And then, yeah, so here's my output right now. But what I want is, I don't want just the URL, I want the public IP that's associated with it. And so that is handled here by the outputs file. And it wants me to call it the cat app IP. And where you get this information is back here in main. I've got a public IP address that's called catapp-pip. And I've got some specific bits that I'm controlling in terms of configuration, and you'll see here in just a quick second that there's a lot more information that's there. So if I go back to my outputs. So if I just do that, and then I run refresh, it's going to show me all of the, what did I do? Try that again. Told you this is your opportunity to see Gary look foolish. Oh, is it called Catash? Did I underscored it. Somebody in the chat's laughing at me right now, I guarantee it. Cat app.
So it's not the, isn't it pip?
Oh, God, yep. All right, so if I go back, and I think it's this, isn't it?
But from that, just you can see how where the error's been cleared calling out. It's actually defining what the problem is. So in that case, it was, I haven't declared the resource. Obviously, it means that that resource isn't known, as opposed to, you know, the invalid expression is around what the declaration is. So Terraform does a really good job, and it's a core component that the founders have pushed being developers into the generation of code, that any of our products have really clear delineations about what the error codes are, not just, you know, 500 or, you know, not found,
Yeah.
or failure, because they've spent years trying to debug those types of things, and it frustrated them. So having having developer founders means that a lot of emphasis is put on having good output and clear, concise messaging.
Which I very aptly demonstrated is all useful as long as you actually go and look at it instead of just keep trying and hammering on it because you're getting more and more stressed. So really, really great to have that information. And it's really important to actually look at that rather than just keep hammering on the infrastructure. So go and read those debug messages, folks. It's always helpful. Okay, so all I've done now is you'll see that there's a lot more information that comes out of that particular object, and I only want to reference the IP address. So I'm going to run refresh one more time. And now I know that this is what output I'm going to get. So now if I actually want to call that and get the actual just output, there we go. And hopefully thus endeth the opportunities for Gary to look foolish in front of everybody. But hey, there's still 2 more challenges if I remember correctly. Right, so with variables, you define the variables in the variable TF. You can then override that with TF-var, so you can override the defaults with TF-vars. But there's other places that you can pass variables, so you can apply them on the command line when you run your Terraform apply. You can set environment variables in your shell environment, and there's a set of precedents on how things override each other. So definitely encourage you to just run through these. I'm just going to copy and paste them because I've clearly shown that I cannot. Is it Control-Shift-V? Somebody in the chat was saying that there is a way to
Control-Shift-C.
That's for copying, but is it Control-Shift-V? Will that do the same thing for pasting? Nope. That's fine. We can watch Gary type and do horrible, horrible things.
Shift insert, someone says.
A Control-Shift insert? Sure, why not? So this is going to now go and provision the application, but it's going to set the height and width variables differently so that the picture of my cat is going to show up at 600 by 800 instead of, I can't remember what the default was. By the way, this is a great demo to use for if you're trying to get a senior stakeholder across what's possible. Going and just firing up the cat app, which I think is, there's a GitHub repository for this Terraform template. So you could go and stand this up for yourself to demonstrate. It's really quite a powerful thing to just get people across what's possible.
There is. I'll see if I can find it.
Okay, so we'll do our Control-Shift-C and no. So people are saying it's Control-Shift-C works, huh? Yeah, not working for me, but I having done this a few dozen times at this point, I can assure you that you do get the properly placed cat. And then those of you who are dog fans, we won't name any names. And then I'm going to skip over the last one, but you'll see really quickly that you can also go and set place bear instead. So different ways to apply variables. Really valuable, not so much from interactive, but really valuable depending on what your CI/CD pipeline looks like, what your tooling looks like. There might be different reasons why you might want to use environment variables versus command line invocations versus using the TF-vars file. So I'm going to let that one just complete real quickly, and then we'll move on to the next. I think somebody in the chat was telling me what I'm doing wrong. Use shell to copy paste. It's fine. I think it's better for you guys to actually get to see the awe and joy that is HashiCat app for yourself rather than see it on my screen. So that way it'll keep you guys honest and you know that you've actually done the lab, not just watched me do it. Okay, last quiz. David, when does this actually get shut off?
When I drop it. So
cool. So we can hold you here for hours, guys.
So, but I am conscious of time, and
yep.
And so if we aim for the 1/2 past, I think we're good.
Yeah, I think that's right. So the answer to this question is that the TF-vars file lives above all other things. So if you have it defined in TF-vars, it doesn't matter what your environment variables are.
I also put the HashiCat Azure into the Git repo into the chat window for people that want to copy and paste it.
Beautiful. Beautiful. So the last two is going to demonstrate the value of the Terraform Cloud, which this was launched this year, wasn't it, Dave?
End of last year, so it's
okay.
It's not quite a year old.
Right. So one of the big challenges people were having is, Terraform was great for individual people keeping their local Terraform state, but as soon as they started to try and share that out and have multiple people working across the same Terraform state file, it became a little bit difficult to do. And a variety of different people came up with a variety of different solutions. But the Terraform Cloud solution is obviously, a really best practice solution in terms of it's a free for you to sign up account. In fact, mine's already signed up. I should be able to just get right into it from memory. Yeah, it's already successfully signed me in. So I am a Terraform Cloud user, but then I can go and create workspaces, and it's a great way for multiple people to share workspaces and share their Terraform states across. So if I go ahead and create one, go ahead, Dave.
I was just going to say this is also that the mechanism for using Terraform Cloud is also that stepping stone between I need to start sharing I'm not working on this as an individual. I'm starting to share it across a group or practitioners, but I'm not yet at a position where I'm fully deploying TFE across my organization. So how do I get that next taste? And there is going to be there is actually a paid version of this above this, which then allows for some of the enterprise features as well. So Sentinel and cost association also then comes in over the top of this, which transposes into those Terraform enterprise components.
Yep. Cool. So all I've done is I've gone and created my workspace and I've set it for local execution. Obviously, you can do remote execution as well. And then from memory, I think the last challenge is actually just to go ahead and start sharing my state up.
Yeah.
Which is great.
And this is where we're talking about being able to manage those states. So taking this from instead of it being local on your machine and seeing that the terraform.tf state file
and locally here, I'm pushing that back up to be held within Terraform Cloud. And that remote state that we were talking, or I was talking about earlier, and that management of that state, how you then share that, how you can use that across and pull that across multiple workspaces, because within separate workspace they now have a state file that they can go and look at and understand what that resource is. So that opens up that ability to change those. And so this is where the real power in using Terraform and particularly across an organization and multiple users really comes into its own.
Yeah, that's it.
I don't know if you just want to go to that so that page where you have the variable files. So one of the questions that I was asked a lot through the chat was how you could more securely leverage and store variables. Obviously, within the Terraform paid version, you can leverage the Terraform variables here, and when you input those variables, it actually has the ability to then obfuscate and secure them using Vault underneath. So it actually will mean that those input parameters are hidden and away from prying eyes, and also from code sources.
Yeah, that's really the big one, is you don't want to have anything that's, you know, API keys, any sort of operational secrets. You definitely don't want to have those in any sort of Git repos, especially public GitHub repos and things like that. That's a great way to get owned. And so storing them in something that's secured by Vault, for example, is fantastic practice. Inside Azure, there's Azure Key Vault, which integrates very nicely. And in fact, really great practice is to run Vault in front of Azure Key Vault, so that you have consistency from the API perspective, and then you've got a hardware-based HSM sitting behind it. So lots of different ways to solve the problem. You know, there's not one that's necessarily better than another one. It's the one that you know, and the one that maps for your particular requirements. So with that, I could go through and set this all up. You literally just follow the recipe, and at the end of it, you get a cake, which I'm happy to do. But I think at this point, we're right at time.
Given time, I think we're, to be respectful of people's time, I think
that's it.
We need to call it. I would just like to say thank you to Gary, obviously, and letting him and getting him to talk. I really appreciate it. Also, thank you to everybody who attended and for staying on well and truly after the session. I really appreciate that too. There will be a follow-up email. In that, there seems to be quite a common request for sharing a recording, so we probably will share a recording of it, and we'll put in a mechanism for you to all be able to put feedback. We'd love to hear whether this, how valuable this was for you. If you'd like to see more of these, if you would share these with a colleague to run through a similar session like this again. So thank you very much to everybody who attended, and thank you very much to Gary. I'll pass it over to you to hand out and finish up.
No, that's it. Again, really appreciate everybody sticking through. We definitely want to run more of these workshops, and so any of your feedback is going to be welcome and appreciated, as constructive as you like. And with that, I think we'll turn you back to your day. Have a wonderful rest of the day, and stay safe. Look forward to doing this again.